All right, guys, I've got some advanced examples for you now. So brace yourself. What if I have the square root of a minus 10 and it's equal to another square root of a minus 6? All right, so let's take a look at this. I'll go ahead and tell you this one might not have a solution. And if you understand transformations, maybe you can tell me why. Let's see what we can do. We usually start by squaring. I'm not going to add 10 to the other side because it's still going to be a radical plus a number. So I'm going to start by squaring. And if I square that, then it'll look like this. A square root of a minus 10 quantity squared equals square root of a minus 6 quantity squared. All right, now the right side's simple. Your radical and your square cancel out, so you get a minus 6. Your left side, though, you got to think about it. I've got a binomial, so I'm going to have to say square root of a minus 10 times the square root of a minus 10. All right, which for those who have a tough time multiplying binomials, no big deal. Square root of a minus 10, square root of a minus 10. Think of them as two factors, right? Square root of a times the square root of a is a. All right, it's technically the square root of a squared, just a. This is minus 10 square roots of a, and this is minus 10 square roots of a, and this is plus 100. So I'm going to say this is equal to a minus 20 square roots of a plus 100 equals a minus 6. Let's see what we can do. Maybe there is a solution. We'll see. I am going to subtract a from both sides, which will essentially cancel them out. And I'm going to subtract 100 from both sides. So essentially I've got negative 20 square roots of a are equal to negative 106. So, no, we'll have a solution. Okay, maybe. I'm going to divide by negative 20, so the square root of a is equal to negative 106 over negative 20. All right, in other words, the square root of a, and I can run that through a calculator real quick. What is negative 106 over negative 20? And apparently it's 5.3. So the square root of a, maybe this will work, maybe. Square root of a is equal to 5.3. So all I have to do now is square, all right, both sides. So I get a is equal to 28.09. All right, and it's like, I have arrived, I got it, 28.09. Well, let's see what happens. I always have to check these. So when I substitute the square root of 28.09, take away 10, I get the value negative 4.7. All right, and if I substitute it into my right side, right, square root of 28.09 minus 6, that's a positive number. Take the square root, I get positive 4.7. So even though they're very, very similar, these are not the same solution. So there is no solution to this. All right, and if I could explain a little farther, you should have expected no solution, right? Why? Because if you think of your transformations, right, well, think of the square root of x and shifting it down 10 units. Well, you get this function, the square root function shifted down 10 units. And then think about finding an equality with a square root function that has been shifted to the right 6 units. So that's this guy over here. If you really think of it, you're just looking at transformations. When are those two ever going to be the same? Well, never, right? Never. They're kind of like infinitely parallel, all right? No solution right there. So hopefully that helps you out with solving that third level, that advanced. All right, let's summarize some of the important steps. I squared. All right, squaring gets rid of most radicals. All right, actually, I mean, you square a radical, it gets rid of it, right? I have to pay attention, though. If I square a binomial, meaning if I square something that contains two terms, I have to FOIL, or use a box. Notice this left side is a binomial. The right side is not a binomial. The right side is a square root with a binomial inside. So when you square, you're really getting rid of the radical and you're left with a minus 6. That's different from squaring two separate terms. All right. So hopefully those are some helpful tips that can help you with very redundant, that can help you solve these equations. Feel free to play the video back, look at the examples. This is something that you can definitely do. You just have to work for it.